Welcome to our lesson in polynomials. So, we will see what are types of polynomials and how to find the degree and basic structure. So, the first one is degree of a polynomial. So, we judge various, we call it first degree polynomial, second degree. What is this degree? So, it is the general, for example, will tell you with example. Degrees of all variables are added. So x is variable, y is variable. Suppose we mention x square, y square. This is the fourth degree polynomial. Why? How we write this? X multiplied by x multiplied by y multiplied by y. So there are 4 degrees in this. This is a fourth degree polynomial. Xy is a second degree polynomial. If x to the power of 2, it's second degree. X square, x to the power of 4 is the fourth degree polynomial. So if it is ax square, a is a constant, x square only criterion, it's a variable. So it's a second degree polynomial. So the degrees of all variables are added. Next is, we'll come to homogeneous. Homogeneous, the word is homo means all the terms in the expression are of particular degree. When we call it first degree polynomial, so we say, suppose say, let us say x, y are variables. X, y equal to. If we tell ax plus by, this is also a first degree, this is our first degree, and also it's a homogeneous. If suppose say there is plus some other things are there, then it is not homogeneous. Plus c is a constant. Don't have any degree. C is a constant. So in a homogeneous expression, so each term is having only particular degree. If it is, you say second degree polynomial. So if it is second degree polynomial, see the standard expression is ax square plus bxy plus cy square. The degree of first term is 2. Degree of second is, degree of x is 1, y is 1, this is 2. Cy square, this is also 2. So there is no constant term in the homogeneous. We call it homogeneous expression. That is, all the terms are of the same degree. So next we have mentioned one more. See, what about cube? This is third degree. Ax cube, A, B, C, D and are all constants. Variables are x and y. There is a first assumption. Definition rather. So x square y is a third degree. Xy square is a third degree. Y cube is a third degree. There is no constant in homogeneous expression. So if you say homogeneous expression of third degree, this is third one. Next, we will come to symmetric expression. Symmetric expression means so this also is homogeneous and also symmetric this term. You see, if a function of xy, the definition of symmetric is if a function of xy if equal to function of yx, if you replace x by y and you replace y by x, then also the equation is same. That is symmetric. So the example is, see, this term is ax square plus bxy plus ay square plus cx plus cy plus d. This is the homogeneous expression. If you replace x by y and y by x, this term will become ay square and the third term will become ax square. If for bxy, if you replace x by y or y by x, then also it's bxy. In case of cx plus cy, if you replace x by y and y by x, then also it remains as it is. That is a symmetric expression. Symmetric means if function of x, so this is x comma y is equal to function of y comma x. We change, then also the equation that is symmetric. This is very important. See, normally in equation we express like this. See, y equal to a function of x. So x we can put any value. Y is the function. The function may behave. It depends upon the x. Suppose x is equal to fy. Then it is symmetric. In these cases, we will be utilizing these properties of symmetry. So this we will discuss later. Next is homogeneous and symmetry. See, what is the difference? If it is symmetric, we are able to understand the degrees are homogeneous means degrees are same. Degrees are 2. So symmetric, if the constant is for x square is same as y square. Then if you replace x by y and y by x, then also equation remains as it is. This is if you replace x by y by x, then also it remains as it is. That is homogeneous and symmetric. Next, incidentally, is homogeneous and symmetric. Homo means same degree. Symmetric means if xy function of xy is equal to function of yx. Next, the product of two homogeneous expression is also a homogeneous expression. So, if function is, for example, a square plus b square multiplied by another homogeneous expression c square plus d square. So, instead of a, you may get confused. A means constant. So, if you take it as x plus y, x square plus y square multiplied by z square plus b square, anything you take, or b you could take, z square plus x, y, z, let us take it, even y dash itself, y dash square, doesn't matter. Then this also is over. If you don't take a square, you may get confused with constant. This where x, y, z, next is y1 or variables. In this you have to mention. That only this has concept, what is x, what is y. So next we'll go to quadratic equation. Quadratic, the standard form of quadratic equation. Quadratic means second degree equation. So we use the quadratic equation very often. For example, the quadratic equation is of the form ax square, in x is ax square plus bx plus c is equal to d 0. This is the standard form of the quadratic equation. General form of the this is general form. So it is ax square plus bx plus c, where a, b, c are all constants. So this quadratic equation we use very often in various calculus of second degree. So in area and various form. So even if the format is in some other form, we can bring the format in this particular format. We can bring the equation and then solve the quadratic equation. So we'll see the next theory. This is this remainder theorem. This remainder theorem we use very often. So if a rational integral function of x, say function x is divided by x minus a, then the remainder is a function of a. This is the remainder theorem. So how we say a function of x? A function of x can be something like x over of 4 plus x cube plus or 2x cube plus 3x square plus some constant. If a rational integral function of x, say function x is divided by, suppose if this is divided by x minus a, x is a variable, a is a constant. If you divide this, you get some function. The remainder is a function of a. So an example is if the function like this is divided by x minus 1, then remainder is a function of a. Function of a is 1 here. X minus a. Compare this. X minus a is x minus 1. So a is equal to 1 here. Or you can compare like this. Minus a is equal to minus 1. So a is equal to 1. Now the remainder is a function of a. What is the remainder? So in this equation, we replace x by 1. 1 to the power 4, 4 by 1 to the power 3, minus 5 into 1 square, minus 6 into 1. What is this? This is plus 7. So we replace the value of x to become function of a is, remainder is 1. If you actually divide also, you get 1 only. You can divide it and check. Remainder is a function of a. Function of a is x replaces the value a. So you are finding out the remainder. So if this is x plus 1, what you do? Here, a is equal to minus 1. Now you replace x with minus 1, remainder is 5. So what do you mean by that? If the equation, this is fx, if fx is divided by x minus 1, remainder is f of a. That is the meaning of it. Next one is factor theorem. The same remainder theorem we will extend it. Suppose you are dividing by x minus a and the remainder is 0. This is remainder. Remainder is 0. Then x minus a is a factor. So what is the remainder theorem says? If fx is function of x is divided by x minus a, you get something, some value plus remainder 0 means if the remainder is 0, that means it is divisible by x, then x minus a is a factor. So we have seen some of the basic functions of polynomial, different types. So it is, we have to remember what is the difference between the homogeneous and symmetric, and how to judge the degree of polynomial. So please repeat this lesson until you understand the basic concept. Thank you. So this is Sri Kumar from Free Maths Tutor India Limited. Thank you.